Good morning, everyone. My name is Pravinraj Manimaran, and my fellow crewmate name is Nazwan. Today, I'm going to present about the project management project. The project is titled IoT-based smart HVAC monitoring and energy optimization system. Now, I'm going to talk about the problem statement. HVAC systems operate for long hours in Malaysia, hot and humid climate. So, it is resulting in high energy consumption and also increased electricity costs. Most conventional HVAC systems lack of real-time monitoring, and it is making it difficult to track performance and energy usage effectively. So, as a result, issues such as energy wastage, poor indoor air quality, and undetected systems faults often persist. In addition, maintenance practices are largely reactive rather than preventive, and it is leading to higher operational costs and reduced system efficiency. And now we are looking at the system that we proposed. So the IoT-based system that we proposed for real-time HVAC monitoring by using sensors, Wi-Fi microcontroller, and also cloud platform. So it will monitor the temperature, humidity level, and also carbon dioxide concentration and energy consumption. So the data will be visualized through a web-based dashboard, and also it is supports data-driven decision making. So now I'm going to talk about the system's description. So the temperature and humidity sensors access to thermal comfort, and also carbon dioxide sensor will be monitoring the indoor air quality. The energy meter will be tracking the HVAC electrical consumption. The microcontroller will be sends the data to cloud platform, and also dashboard will be display the real time and historical data of the system. Now we are going to look at the work breakdown structure, which is WBS. It is on three levels. For level one, it is on IoT-based smart HVAC monitoring and energy optimization system. So under that, there is project management, system design, hardware selection, software and dashboard development, and also testing and documentation. For level 2, we selected the system design. So under system design, there is identify HVAC parameters, select suitable sensors, and also design system. So for level 3, we selected installation sensor selection. So the sensors that we're going to install are temperature and humidity sensors, carbon dioxide sensor, and also energy meter. And now it is about organization breakdown structure, which is OBS. So the project leader will be coordinating, prepare the schedule, and also he will be do the final submission of the project. And also the system design engineer will be set the HVAC parameters, and also will be the system will be delivering the system architecture. The hardware engineer uh, will be the person of in charge in device selection and also sensor selection. So the software engineer will be building the data dashboard, and also will be involved in the data communication. And also the for the final member, that will be documentation member, uh, which is he will be the responsible for the report and also presentation preparation.
Okay, Assalamualaikum. My name is Muhammad Nazwan bin Abdul Rahim. Okay, today I would like to continue to the next slide, which is task list and scheduling. So this slide present the task list and scheduling plan for the project, outlining the main activities and their respective durations. So the project begins with project planning, 3 days, followed by system design, 5 days, which defines the overall architecture and requirements. After the system design phase, hardware selection, 4 days, and software and dashboard development, 7 days are carried out, with software development being the longer and more critical activity. Once both hardware and software tasks are complete, the project proceeds to testing and validation, 5 days, to ensure system functionality and reliability. So finally, documentation and final report, 5 days is complete for project submission. So that this structure schedule ensure efficient task sequencing, allows parallel activities where possible, and supports completion of the project within the planned 25 days timeline. Okay, so this slide is network diagram, which shows the sequence and dependency of the project activities from start to completion. So from this slide, we can see that we have two lines, two different colors of lines, which is red and the blue. So for the red is the critical part of the project, and the blue line is non-critical. So this project begins with project planning, 3 days, followed by system design, 5 days. So after that, hardware selection, 4 days, and software and dashboard development, 7 days, are carried out in parallel. Once both are complete, the project proceeds to testing and validation, 5 days, and ends with documentation and final report. So the diagram helps visualize the workflow, identify parallel tasks, and ensure the project is complete in 25 days. Okay, so for the critical part, this slide explains the critical part of the project, which is the longest sequence of dependent activities that determines the minimum project completion time. For this project, the critical part is A, B, D, E, and F, which includes project planning, system design, software and dashboard development, testing and validation, and documentation and report. So the total duration along this part is 25 days, meaning any delay in these activities will directly delay the entire project. Although hardware selection runs in parallel with software development, it is non-critical because it has some scheduling flexibility, which is float. So in contrast, software and dashboard development is the main driver of the project. Uh, uh, the main driver of the project timeline. Therefore, close monitoring of critical activities is essential to ensure timeline project completion and avoid delays in final submission. Okay, for this slide is the cost estimation. As you guys can see, it has five type of the components. So it explain the cost estimation for the proposed IoT-based smart HVAC monitoring system. So the budget focus on essential hardware component required for system monitoring and data collection. So the temperature and humidity sensor costs Rm 40 ringgit, and the CO2 sensor costs Rm 120 ringgit, and the energy meter costs Rm 150 ringgit. So as these components are critical for monitoring indoor air quality and energy consumption. So next, a Wi-Fi enabled microcontroller costing Rm 60 ringgit is used to collect sensor data and transmit it to the cloud platform. Furthermore, an additional Rm 80 ringgit is allocated for miscellaneous items and contingency, covering wiring, connectors, and unforeseen expenses. So the total estimate project cost is Rm 450 ringgit, making the system affordable and suitable for small scale implementation. This cost estimation demonstrate that effective HVAC monitoring and energy optimization can be achieved with a relatively low investment while delivering significant benefits in energy efficiency, indoor air quality, and maintenance planning. Okay, for the next slide is expected benefits. So this slide highlight the key benefits of the proposed IoT-based smart HVAC monitoring and energy optimization system. In terms of energy efficiency, continuous monitoring of HVAC energy consumption helps identify energy wastage and inefficient operation, enabling corrective action that can reduce energy usage by at least 10%. This leads to lower electricity costs and more sustainable building operations. For indoor air quality (IAQ), monitoring CO2 levels ensure adequate ventilation and helps maintain concentration below 800 ppm, improving occupant comfort, health, and productivity. From a maintenance perspective, real-time data allows early detection of abnormal system behavior, shifting maintenance from a reactive to a preventive approach. So this reduces system downtime, minimize repair costs, and extend the lifespan of HVAC equipments. Okay, for the conclusion, overall outcome of the project, the proposed IoT-based smart HVAC monitoring and energy optimization system provides an effective solution for improving HVAC performance by enabling real-time monitoring of key parameters such as temperature, humidity, CO2 concentration, and energy consumption. By using IoT technology and a cloud-based dashboard, the system supports data-driven decision-making to enhance energy efficiency and maintain acceptable indoor air quality. From a project management perspective, this project demonstrates the practical application of key tools such as the work breakdown structure, WBS, organization breakdown structure, OBS, scheduling, and critical path analysis and cost estimation. Overall, the project promotes sustainable engineering practice and prepares students for real-world industry application involving smart building and energy management system.
Thank you.